Hello, St. Tammany Parish K-5 science educators. Tom here with Amplify Science, ready to showcase our amazing Tier 1 rated K-5 science program for Louisiana. So starting off, I want to go through the housekeeping and agenda items for today's video. We're going to talk about the program components, those teacher resources and student resources that bring science alive in your classroom. I'll be doing a program overview and then diving deeper into a unit and lesson walkthrough, and then wrapping everything up in our video with professional development. So starting off, I really want to make sure that you understand you have a customized website that you can access with a special password that you're seeing here. You can also scan the QR code to get access to that website, which has more details about our scope and sequence for both K-5 and 6-8 and other resources to help you in your selection process. As you'll see, Amplify Science has a lot of great resources that we can share with you. And starting off, I really want to talk about those exceptional components in which teachers get to use to teach Amplify Science. So you see I have a lot of resources behind me. And so what you're going to find is that each unit within Amplify Science has its own curriculum kit or set of materials. What you're seeing here in this screen image is what a second grade teacher would receive. So we have the primary kit, which is this one here, like we have an example of right here, but also there's additional materials. We want to make sure you don't have to go out and buy anything. Everything is included in our material kits to make teaching really easy for you. So we're going to start off with a digital and print teacher guide. So I have the print teacher guide here. It's always nice to have this print resource as a backup, or just plan the way you like to plan. When we're looking at the hands-on materials, there's enough hands-on materials inside our kits for a class size of up to 36 students. That means working in groups of 2 or 4 for the hands-on experiments and investigations. So all the great hands-on resources are in here for you to get set up in about 5 minutes to do any kind of lab or experiment. We also have inside this middle divider section within our box, you're going to see we have 5 unique titles per unit of the student text. And each one is used over the course of different chapters typically. There is one, like this one here from Balancing Forces, and this is called a reference book. And the reference book is used throughout for students to learn how to get information from text that is more of a dictionary or a reference kind of resource or an encyclopedia. So all these are included. There's 18 copies of each of these. So a lot of great readers inside the kit. 18 copies is designed for that class size of 36 that I mentioned. Partnered reading approach. We know informational text and reading strategies are embedded in our program to allow students to work together and collaborate like scientists, even when they're reading. Additionally, you're going to see unit questions, chapter questions, vocabulary cards, pre-printed for you on heavy cardstock. So your word wall will become alive with all the resources so that you don't have to print. It's done for you. But let's say my Balanced Forces goes missing. No worries. You don't have to buy a whole new kit. You can print any of these resources on demand from your teacher platform. The other components I really want to talk about are student notebooks. So students will have this consumable graphic organizer and reflection space. So for every unit, a student would have something like this one's from Waves, Energy, and Information. And students will use this to complete and show and demonstrate their work. This provides an even playing field for all students to then really jump right in and demonstrate their understanding on what they're learning throughout the course of the unit. As we move forward, you'll see K-1 educators get those same small books, but you get the special bonus of the ultra large flip book. I love these. So you can have that close carpet reading time, such as this one here, learning about, plants and animals, and here tortoise parts. So you can have that close reading experience with your students. I also want to just preview all of the text also are available digitally with an audio read aloud function for the student. We also have a video of all the text of a real teacher reading the text as well. We want to make sure that we don't let reading be a hindrance for students as they learn science. So we really support reading instruction with our materials as well. So Amplify Science looks different. We take a phenomena-based approach. We're going to engage students with a real-world problem, and then we're going to collect evidence from different sources that you see right here. And in that process, students are going to construct a deeper explanation to where then eventually they can apply that to solve problems on their own. That's the Amplify Science approach. Let's go a little bit deeper.
So now let's take a look at this inner feedback loop of collecting evidence to construct increasingly complex explanations. This is done through our patented do, talk, read, write, visualize approach. Do means hands-on activities. Students will be engaged in hands-on explorations and investigations, but we don't end there. We want students to have discourse. And so the talk phase, we enter the talk phase within Amplify Science. Of course, my students love talking in the classroom, but instead we want them to talk about science. We embed 8 different discourse routines to make it easy to have that scientific discourse in the classroom. Things such as think, pair, share, you're going to be very familiar with. And then we want students to read. Read for depth of understanding and get evidence from text from those readers. And I'm also going to show you the digital version of those same text. So here I am with tortoise parts, and you can see here students have access to the digital flipbook, and they can go through and see the same images as in the print version. But also we have some nice features here with the live speak text function. So the text will be read to the students as they see fit. So students will have access to the digital version to gather information from text as they work through our program. So do, talk, read, and then students write their findings in the investigation notebooks. Now keep in mind, teachers have access to any and all of the pages in the notebook and can add them to Google Classroom or other resources in which you want students to work and complete their work. So you have the print version, but you also have access to the digital versions as a teacher to share out. And then visualization. We have videos, multimedia, apps, modeling tools, and simulations that really bring all of this learning home for the students. I'm going to show you some of these digital tools. So I'm starting here with a modeling tool. This comes from our unit, plant and animal relationships. And so students are going to be able to easily drag and drop these acorns. Now, if I put it on a sidewalk, nothing happens. I put it in the soil, oh wow, a tree grows. Let's say I put it in the shade. It doesn't grow. So students at this more basic level are going to understand that, plants need sunlight and they also need soil and a place to get that water into their roots. So we're going to see that with this basic modeling tool. The next tool I'm going to show you is called a data tool. So in this particular case, we don't expect students to make Excel spreadsheets, but we can really show some great depth of understanding where students put in population numbers. Maybe they're researching this red squirrel population over time, and maybe they're seeing something happening as they work through the data. And one of those science and engineering practices and cross-cutting concepts working together. So science and engineering practices, looking at data and analyzing it, and a cross-cutting concept I can see here is a pattern. Over time, there is a change in the population. So students can visualize with these modeling tools. The next modeling tool I'm going to show you comes from our balancing forces unit. What you're seeing here are actual ring magnets that we include physically in the hands-on materials. Students will manipulate those ring magnets, but then we want them to demonstrate their understanding, showing that one magnet can be pulled to the other magnet, and that's a non-touching force. And of course, the other magnet would then be pushed, and that's a non-touching force. At this point, we then introduce those other vocabulary words such as repel and attract. The next thing I'm going to show you is a simulation. So in this unit, students are going to be electrical engineers trying to figure out why the town is having blackouts. And so there's different energy sources that students can select. I'm going to start with the sun. Students will actually use real solar panels from our material kits to build circuits and make a motor run. So I'm going to connect that solar panel digitally. And let's go ahead and add a motor, and then I want that motor to do something. If I choose the wrong combination, they will not work together and make that system run. Now my run button is glowing in the upper left, and I can see that light is becoming electrical becoming motion, and then stored motion until I transfer that out. Now as that finishes, my Analyze button glows. Here comes some data. Energy transferred in was 50. Energy in the system was 43. So students will ask, Mr. Gant, where'd the other 7 go? Well, if I look over here, thermal. Oh, we lost 7 of that energy as thermal. That means heat. That gets the students' brains thinking. Remember, they're electrical engineers trying to figure out the blackout. Maybe the grid is having overheating issues. And so that can lead them to answer some more of their questions. I'm going to show you the sorting tool that follows along with this same unit. So students will then be able to, make an energy converter such as a fan. And I know I have to plug the fan into the wall. And then the fan's going to make a little bit of sound as it spins around. So these drag and drops and modeling tools really allow students to demonstrate their understanding at a much deeper level. So do, talk, read, write, visualize. This process all comes together to really allow students that phenomena-based learning, where students explore real-world problems using those 21st century tools and resources. And so that's one reason to choose Amplify Science. I'm also going to explain how we're flexible, because we know time to teach in every classroom is different. And so we're flexible with pacing. And then teacher planning and assessment. Our assessments are built in. Teacher planning comes in 3 easy steps that I'm going to show you. And of course, we want to support reading and literacy, so you're seeing that integration into science. So Amplify Science uses a phenomena-driven 3-dimensional approach. And phenomena is the questions that are out there. Students are always asking questions and trying to figure out the world around them. And so we're shifting away from topics. Instead, we're embedding phenomenon around a 3-dimensional approach. So instead of teaching sound waves, we're talking about dolphins. A female dolphin is trying to get with her calf. How do they communicate underwater? Or sea turtles. Well, instead, let's talk about sea turtles surviving in a place where sharks could eat them. Energy conversions, a town having blackouts. So we're giving meaningful and relativeness to students, and they can really take away that question that they always ask the teacher, why are we learning this? We're giving them a purpose. Students will go on a problem-based deep dive with every Amplify unit. They're going to actually be a scientist or engineer. They're going to figure out how the real world works and unlock this phenomenal problem. Think of it as an engaging 3-dimensional storyline, but we're also preparing students to think beyond the typical science that they think of as they prepare for college and careers. An example from grade 1, where students are aquarium scientists in our unit's animal and plant defenses, students are rehabilitating Spruce the sea turtle. She's ready to be released into the ocean, but they're worried that she might get eaten by sharks. Along the way, they're going to engage in all the colorful text and gather information as they work through understanding how animals and plants defend themselves. You see an image here of the audio text and also the print-rich environment in the classroom. As we move forward throughout the unit, students are going to watch videos such as the monkey eating or the tortoise. But then we go a little bit deeper in an experiment such as eating a carrot. How do students learn from that? My son completed this unit and he said he came home saying, I learned that our mouth parts are designed to eat certain foods and that many animals defend themselves by their mouth. Going further into the unit, students are going to do amazing hands-on experiments such as this one here, where they're building a model out of the clay that's in our kit. That clay represents the soft body of the creature. They have to find ways to protect it or camouflage it with all the other resources from our material kit. As you can see there, we have some very creative students finding different ways with spikes and shells to protect their soft-bodied creature. In grade 2, a great example of engineering, students are going to be glue engineers. They actually get a letter from the school principal and they have a glue shortage. They have to make their own glue. It's going to be using amazing resources from our kit, such as baking soda, cornstarch. All those will actually end up making a glue that they'll be using for their own school projects. So in grade 3, students are going to try to figure out how a floating train works. This is going to be my model unit for today's lesson. I'm a civil engineer, and this magnetic levitation train has come to our town.
The city of Faraday has arranged for a new train to come to Faraday. The citizens of Faraday were excited about having another way to get from place to place, until they heard something about the train. It's a floating train. The people aren't sure what it means for a train to be floating, but it sounds strange. The mayor of Faraday is worried that people won't ride the train. She needs our help.
And so students will also complete hands-on investigations.
We are going to try and find ways to make these blocks move. In order to investigate safely, only move the blocks sideways along the floor or desk. One way to make the block move is to hook a rubber band on one end.
So students will engage in writing out their findings in their notebook, and then of course reading to gather more information from the text. Along the way in this unit, students meet our fabulous page turner, who is trying to make his page turn in a magazine, all by creating a chain reaction device. Students will then create their own chain reaction devices, showing the different forces at work throughout the unit. By grade 5, students are going to be water resource engineers in our Earth System unit. They're designing a solution to water shortages on an island. One side of the island gets a lot of rain, the other side doesn't have enough.
This is the Earth System Sim. We will use it to learn more about how raindrops form, both at the observable scale and at the nanoscale. In the landscape screen, choose one of 12 landscapes. Each landscape shows the ocean and the land from a side view. You can also see under the ocean.
So students will explore with the simulation and the digital tools as well as the text to solve this problem for West Ferris and East Ferris by creating great ideas and projects. Along the way, they're going to read these amazing books. One that really intrigues the students is Drinking Cleopatra's Tears. They kind of gross out at first when they realize that water is recycled throughout our ecosystem, and they realize that they could actually be drinking the tears of Cleopatra. You'll see amazing projects that students complete in this unit, condensation devices, freshwater collection systems, all as the goal of solving that real-world problem. So when we talk about Amplify Science, we have a variety of units. You'll see in grades K1 and 2, there are 3 units. In grades 3, 4, and 5, there are 4 units. For your planning purposes, no matter which grade level, what level you're teaching, or what unit, 22 lessons per unit. We have investigation focal units, such as needs of plants and animals in kindergarten. We have investigations in all our units, but these focal units really drive home those process skills and those science and engineering practices. Modeling, we have modeling units, such as our sea turtle, building models in that particular unit. Engineering units, our kindergartners get to be pinball machine engineers in grade K, where they're looking at pushes and pulls. And then you saw in the Earth System in grade 5 something as more advanced as water resource engineers. And then finally in grades 3, 4, and 5, we have what's called argumentation units, where students are collecting evidence and they're sharing it out in these town hall discussions that really drive home their depth of understanding. And so students can realize they can pursue all these amazing STEM careers, from food science to conservation biologist to even a glue engineer. Now, I mentioned the flexibility of our units. So units are chunked by chapters, and those chapters include lessons. And each lesson has a series of activity. So if I take my animal plant defense unit, I can see it has 4 chapters. And then when we get to the actual lessons, this is where the flexibility of time in your classroom. So maybe this particular day, I only have enough time to do the reading and then the hands-on activity. I can hit pause and pick up activity 3, the writing, and the teacher-led discussion 4 in my next period. If I happen to have more time that day, maybe I complete these 4 activities and start the next lesson's first activity. So totally flexible for the amount of time you have to teach, and we'll work with you in our professional development to address your instructional periods. We're totally built for 3-dimensional learning. We are not retrofitted, and this is why we are a Tier 1 K-8 science solution for Louisiana. The Lawrence Hall of Science created our program, and they developed this program after the standards were finalized and Amplify Science was created. So we're going to make this shift very easy for teachers to understand. Through every unit and chapter and every individual lesson, we have a 3-dimensional approach. We're taking those disciplinary core ideas of earth, life, physical, and engineering and bringing in those 8 science and engineering practices, what we want students to be able to do. And then how do students think? How do they make connections with our cross-cutting concepts? We're going to anchor that for the teacher around a phenomena, such as a floating train and grade 3 balancing forces. What we provide in both digital and print are 3-dimensional statements. This one comes from this particular unit where students are challenged to explain how a floating train works. That's my phenomenon. Everything in blue are my practices. I can see my core ideas in orange and my cross-cutting concepts in green. So that's at the unit level. These are both in print and digital. When I get to a lesson, oh wow, look at this. I can make this an I can statement. Students can identify patterns in data based upon their investigations of which objects magnetic forces act upon. So instead of a teacher telling students that magnets are attracted to metals that have iron, we're going to have students do a sort. They're going to predict which items that are of the set of materials from the kit that the magnets can be attracted to, and then they're going to test it, and they're going to come up with that pattern. Instead of us telling them, they're going to explore it and understand it at a deeper level. Now, if you look at the LEAP 2025 achievement level descriptors, you'll see they're also color-coded, and where Amplify Science is pushing students to level 5 with this advanced level of inquiry and achievement. Now let's talk about assessments. Every unit starts with a pre-unit assessment, and it ranges from discussion, modeling, maybe a written explanation, all dependent on the grade level as well. Our little learners in kinder and first, it might be more of a discussion, as you can imagine. And then by the first chapter and every chapter that follows, we have a critical juncture assessment. These are critical. We don't want to move on to the next chapter until we make sure everyone is ready. All of my students are ready to progress. And so we provide remediation strategies and tailored notes to help students and teachers, really rework and maybe do a center and revisit the concepts so they're ready to go to the next chapter. Every chapter also has a self-assessment where students really share their own learning. And then on-the-fly assessments. These occur in the actual activities within the lesson. So when we think about those activities, if we can break apart misconceptions at an activity level, students are going to be much more successful on all the other assessments that follow. So we provide the look for. These are also embedded in the slide decks and PowerPoints for teachers in our clickable lesson plans. And then you see the now what? How do I modify instruction? So we're going to make it really easy at point of use for teachers to have these important impacts on student learning. And then end of unit assessment is a combination of targeted discussions, models, written explanations. Now in K1, we have the additional called clipboard assessment tool. Now the clipboard assessment tool allows the teacher to ask questions. Verbally, K1 students can express themselves much better sometimes than in writing, as we know. And so here's the questions and answers that we can guide teachers and students as they work through their understanding. Standard-based benchmark assessments are very important as we prepare for state exams. And so you're going to see we have these starting in grade 3 all the way through grade 8 in our program. Visual stimuli, multiple choice questions, data analysis, and performance tasks. And one thing I really like to point out is our depth of knowledge, all level 2 or 3. The state is pushing students to a deeper level of understanding, and our benchmark assessments also correlate to that depth of understanding as well. Every lesson has a slide deck in both PowerPoint and Google Slides for you. You can fully edit them. You can customize them however you see fit. Once you make that copy, it is yours to manipulate however you see fit. But what's lovely is you don't have to do anything unless you want to. These are complete clickable lesson plans that include images of the text if we're working in text, videos explaining how simulations work, pages of the notebook, and those embedded on-the-fly assessments with the notes in the margin there for the teacher. We also have videos, these awesome videos that I want to share. I'm going to start off with our instructional videos. Imagine having a guest teacher in your classroom. We have a video of a teacher teaching every lesson. This is great for our special ed students, our English language learners, also as a way for us to our own professional development. I can model my instruction off of that as well, absent students and substitute teachers. We have videos of all the hands-on experiments. Great way to learn how the lab is supposed to run, or for absent students, or once again for those other situations that I mentioned. And then we have a read aloud video of all the text. I mentioned this before. We also have the digital version of students pressing play, but this is a real teacher in a YouTube video. The reason these assets are on YouTube is that students may not have a device at home, but they might have a smartphone, and this gives them that access. So when you're thinking about the text that students are going to read, you have the print readers for the students, you have the digital version for the students where they press play and it can read to them, the videos of teachers reading to them, and also the images are embedded in the classroom slide deck for seamless teaching of the literacy component of our program. Now let's talk about the technology in that exploration that makes teaching easy. One thing I want to point out is Amplify integrates with all the LMSs and SIS systems out there. And you see a lot of them appear on the screen, so even if your district changes LMS systems, don't worry, we've got you covered. We can go one-to-one with every student or somewhere in between with a blended model of instruction. You can also print on demand any of those notebook and print resources if you don't want to send them home with students in case they don't bring it back. We don't want to lose those notebooks, so you can also just send a page home by printing it out. We also think of the increase of student-facing digital content. What do students have control over? We don't want screen time burnout with Amplify Science. So in K1, teachers have most of the control of the multimedia. Students have access to the digital readers. those digital flip books. And then the other multimedia is controlled by the teacher. In grades 2 through 3, we introduce practice tools, those drag and drops, those data tables. And then by the last unit in grade 3, we do introduce a simple simulation. And then by grades 4 and 5, we have simulations, practice tools, and student books, all read aloud as needed. And so you can see we're increasing the digital content as well as its grade level appropriate. So let's go into planning. How do we plan for a lesson? I'm going to visit what's called the lesson brief. I would get materials out of my curriculum bin, and I would get my classroom slides either in PowerPoint or Google slide form. And the goal is to shift the instructional model where students figure out, not just learn about science. Instead of asking the teacher, Siri, Alexa the answer, we're going to have them figure out answers more independently for that deeper level of understanding. So now I'm going to go over to the teacher digital experience. So here I am in 3rd grade balancing forces, and you'll notice I'm in the Louisiana version of science, and you can see here up at the upper left the balancing forces unit. As I scroll down, I can see all my different chapters. One thing I do want to point out while I'm here, anytime you need help, we have a live chat right here in the bottom corner that is monitored from our team from Atlanta daily, even on weekends. So you can contact us, send us a message, and you'll get a response. We also have an 800 number, but the live chat works beautifully. So as you can see here, we start with why does the train rise? Why does it rise without anything touching it? Why does it fall? Why does it float? And then why does it change from floating to falling? So we're getting more complex over the course of the chapters. I'm going to start with lesson 1.2. So here I can see there's the teacher introducing the problem, there's student discussion, there's a hands-on activity, and we're sharing observations. And over here on the right, first thing I'm going to do is get my PowerPoint or my Google slide deck and go through that. That's a clickable lesson plan that really is the easiest way to prepare. And then I'm going to scroll down to my materials and preparation. And so we even provide plastic Ziploc bags to organize the materials for the groups of students that are going to be working together in pairs. And then I want to check out my differentiation brief. Every lesson has a unique differentiation brief. The reason I say it's unique is that each lesson has different demands on the students, and so the brief is there to support those demands. So you'll always see supports for diverse learners, any potential challenges in the lesson, strategies for my English language learners, and some of those strategies are great for other emerging readers. And I go a little bit further. Those students who need more support, here's some sentence frames and sentence starters to help them. And then those who need more challenge, the honor students, those fast finishers, how do I keep them engaged? So every lesson has supports for all of those different levels. So now let's go to teach this lesson. So welcome students, we're going to start lesson 1.2, making an object move, and we're going to do that by discussing some initial ideas about our floating train. So students are going to watch the floating train video, and they're going to start coming up with their own ideas. And we're going to talk about how scientists investigate how things move, float, and fall, and we're introducing that think, pair, share routine. We're going to think about the question, pair up, talk about it, and then share it out. What do you think could make the train rise off the track? Now your students are going to come up with all sorts of ideas, Harry Potter, magic, helium, and we're not going to say no to any of those. We're going to collect those and say, you know what, we're going to have to find evidence to support those claims. And then we're going to introduce the chapter question. Why does the train rise? What is making that train rise? And so we're going to just figure out how things move initially by doing a making blocks move experiment. Here's the embedded video of the teacher explaining how this is to run. I'm going to fast forward it to this point.
Now you will try and make the block move yourselves. These are the materials you will be using in your investigations. Try different ways of moving the blocks, even if you aren't sure they will work.
And so students will make observations, and this is an important vocabulary term, using our 5 senses to learn about something. Obviously, we're not going to use the sense of taste on our objects today. So let's find ways to make those blocks move. Here's the page 2 in your investigation notebook. Record what you observed with words and drawings. So you give your students time to complete that. But once again, scientists share out information. So once we've completed our hands-on, we want to share that information and gather that as a whole class in our class observation table, where students are going to share which objects they used, what their observation was, and if they can classify it as a push, a pull, or not sure. It's okay if they're not sure. We're going to be revisiting that as we get more evidence. So we're completing that class observation table, and the students will recognize there's a pattern, that most of the things that they're manipulating are called touching forces. And then we relate that back to the train, that something must be acting on the train, some kind of force to make it move. But is it a touching force? Now, when we enter the next lesson, this is a literacy-driven lesson called Forces All Around, which is the title of the book. So students will have the copy of the book with their partner, and we're going to look for evidence of forces. The teacher will read the first page and explain that also the visuals are very important. We can find evidence from the pictures as well as from what we read, and we're going to mark the page with a sticky note, because then we're going to transfer that information into our student investigation notebooks. And so we look at the visual here, and students are automatically drawn to the skateboarder or the boy going down the slide. And so they see forces at work there, and we can let them know you can have more than one force on a page. And so you can mark those pages with multiple sticky notes. At the end of this reading lesson, we're also going to add that same evidence to the classroom observation table. So we'll have hands-on experiments, and then right below that we'll have evidence collected from text, showing the value of first-hand and second-hand evidence as we work through the curriculum. Along the way, students are going to do some really cool experiments. This one's called the floating magnet trick, where they realize if they reverse the poles on these two ring magnets, that magnet will actually hover in the air like our floating train. Students will also engage in engineering tasks in this particular unit called the Floating Paperclip Challenge, where these are the materials from our kit, and they find ways to make this paperclip hover in the air. So you can see here a lot of great different designs, and they're all successful as they're drawing out their models that they created, showing balanced forces acting on an object. At the end, students are going to read about bridges and how we keep those balanced. And think of all those amazing bridges throughout Louisiana that students can use as an example and then demonstrate their understanding. So this all ties together in our ways of which we support all learners in the classroom. Students are going to create several anchor charts, as you saw. We're going to start every unit, though, with a prior knowledge and a prior experience routine with a what we think we know in our experiences chart, where students then visit that at the beginning and end of each chapter and add to it, take things away, and it becomes a whole class visual representation of their learning. We also understand that students come in with gaps in knowledge, so we want to make sure we have an access point for all learners. With Amplify Science, units start with a progress build called Level 1, and our assessments are tied to these levels as well. So at Level 1, a force is a push or pull that acts between two objects. Students know they can push or pull things, and we tap into that knowledge. By Level 2, we introduce touching and non-touching differences, gravity and magnetism. Those are non-touching forces, but they definitely have impact on the objects around us. And then by Level 3, more than one force can act on the object at the same time, and you can have balanced forces as demonstrated with those models of the floating paperclip and the magnet tricks as well. The goal then is for students to really understand that anchoring phenomenon, and then at the end of the unit you'll see a twist to really extend that thinking to what we call an application phenomenon. You saw that by designing a bridge. And if students can design that bridge and show the balanced forces on it, they're demonstrating in that performance task their depth of knowledge, such as you see here. I mentioned every lesson has differentiation supports. I want to really drive that home because that's really important to addressing all the different learning styles in your classroom, but also just the thoughtfulness of the multiple at-bats that we have through the do, talk, read, write, visualize process allows students to really develop their depth of understanding. But also we want students to realize they are represented and can do science. So you'll see ethnically diverse scientists throughout our program, as well as girls, women, and people with disabilities all being great scientists or engineers. Even our fictional characters are multicultural and really explore and learn science as they work through. And lastly but not least, professional development. How do we support the teachers? We want to make sure that you are trained as deep as you need, and we start with what's called a grade level orientation, where each grade level will be separate and we would do deep training, and that's that implementation training you can think of in the summertime before school starts, and then administrators and coaches orientation as well. But then we can develop a multi-year plan, which makes sure we get those foundations going, but then we support you with strengthening sessions. And this is just an example of the multitude of professional development sessions we can offer. And so we support you with guided planning and other ways as the strengthening phase. And then we enter the coaching phase as needed, where we come into classrooms, we teach lessons, we debrief, we do walkthroughs, and we really help you review the data and where we can help you really grow into our program over the course of the adoption. We also support all the families. We have a dedicated caregiver website and support line in both English and Spanish. This is a great resource. As a parent of a student who is using Amplify Science, I love going there to find questions I can ask my child to see how his learning is going. And you'll see transformations in classrooms. These come from other users in Louisiana, where we have a Bengal Tiger reserve created by a teacher around that unit phenomenon. Different resources used in different ways, as you can see here, with creativity. Using our kits to grow those plants when we talk about the needs of plants and animals, and building those creatures to withstand predators, as well as interactively working with the text and the notebooks. And so why choose Amplify Science? We are the only K-8 approved Tier 1 program using 21st century tools and resources. We're flexible to meet the needs of your classroom. Teacher planning and assessment is built in 3 easy steps, and we're going to support reading and literacy throughout the instruction. Thank you for taking the time to watch this video, and we look forward to working with you at St. Tammany Parish.